So, welcome back to Aisha's Academy, and in today's video, we're going to be going through perpendicular lines. So, let's get right into it. Okay, so perpendicular lines are basically the opposite to parallel lines, essentially, because with perpendicular lines, it's basically where two lines are going to meet to form a right angle, whereas perpendicular, they run next to each other like train tracks kind of thing. So, here is showing an example of two lines. They're meeting and they are forming a right angle. So if two lines are perpendicular to each other, when you multiply both of their line gradients, they make -1. And there's a reason why this -1 plays an important role, because we can use that -1 to essentially work out the gradient of a perpendicular line. So let's say if we know that the gradient of the line M1 is -2, then to work out the gradient of another line, this other line, where I'm using M because M is usually represented by gradient in your y equals mx plus c. So to work out this gradient of M2, put a question mark, how would we do that? We do that by basically dividing the gradient of M1 by -1. So it's going to always be -1 divided by the other gradient of the other perpendicular line. So by doing -1 divided by -2, you should be left with an answer of, see if you can work it out before it comes up. You should be left with an answer of 1/2. Okay, so another way as I think of it is flip it and stick a negative in front of it if you don't prefer this way. So now we're going to go into some practice questions. So, example 1, numero uno. So, let's say in this question they've drawn a lovely rhombus, given us the coordinates for A and the equation for diagonal DB. Wants us to work out the equation of diagonal AC. So, notice how AC is perpendicular to line DB. So, we can find the perpendicular of gradient AC. We can do that by doing -1 divided by the gradient of line DB, which it tells us the gradient is 1/2. Okay. So -1 divided by your 1/2 will leave you with an answer of -2, also known as flipping it and sticking a negative in front. So now that we have our M, our gradient for the line AC, so far we can fill in the gaps. So it's, rather than writing y equals mx plus c, we can actually write y is equal to -2x plus c. But we still need to work out what c is. So how we need to do that is by substituting x and y values to work out what c is. So we know the coordinates of A, which is 511. So we can substitute that 511 into this equation, rearrange it to work out what c is. Okay, so bear in mind you need to only use coordinates that are going to fall within that line, and point A is a point on the diagonal AC. So this will leave us with 11 is equal to -10 plus C, because -2 times 5. Rearrange this, it's going to be 11 plus 10, which is 21. So C is equal to 21. Therefore, our final answer we can write is y is equal to -2x plus 21. Example 2, numero dos. So in this case, it's given us the equation for line 1. It wants us to basically work out the equation of line 2. So same method as before. We've been given that the gradient of line 1 is -2. So we're going to do -1 divided by -2. And that should leave you with an answer of 1/2. So now that we have that 1/2, we know that the gradient of line 2 is 1/2. So we're going to substitute that 1/2 into our y equals mx plus c. So rather than y equals mx plus c, it's going to be y is equal to 1/2 x plus c. Then we're going to substitute the 0.56, because that's the point that actually falls on line 2, into that formula to work out what c is. So it's going to be 6 is equal to 1/2 multiplied by 5, because that's the x coordinate, plus c. Then we're going to basically simplify this, rearrange this to work out what c is. So 5 times 1/2 will leave you with an answer of 5/2, and then that's plus the c is equal to 6. And then to work out what c is, we would do 6 minus 5/2, which would leave with an answer of 7/2. But with this question, bear in mind, we can't just leave it in the format of y equals mx plus c like we did for the other one. This one, they specifically want you to leave it in the form of ax plus by plus c is equal to 0. So I'm first of all going to write it in the format of y equals mx plus c. And bear in mind, it wants these values to be integers. And at the moment, we've got fractions, which is a bit of a problem. But don't worry, not impossible. So we can multiply the whole equation by 2. By doing that, we're removing the fraction and the whole numbers. So that's 2y is equal to x plus 7. Shift everything from the right hand side to the left hand side, so it's equal to 0 as they want. So that's going to leave you with 2y minus x minus 7 is equal to 0. And that is your final answer. Really important to note. So here it's basically saying that line 2 crosses the x-axis at point A and the y-axis at point B. So it wants us to work out the coordinates. So remember, on your x-axis, every value of y is equal to 0. And so because of that rule, we can substitute y is equal to 0 into the formula. So again, you can substitute this into the final answer that you left of the 2y minus x minus 7 equals 0, or you can substitute into the y equals mx plus c. Either way, you should actually get the same answer. So by substituting y is equal to 0, by rearranging this and solving this, your value for x should just be 7, okay? Then on your y-axis, every coordinate on your y-axis, x is equal to 0. So therefore, we can substitute x is equal to 0 into the equation of line 2. So that would be y is equal to a half times 0 plus 7 over 2. And based on your general knowledge of maths, we know that anything multiplied by 0 is going to be 0. So this one's a slightly easier answer. So therefore, you should know that your coordinate for B is going to be 7 over 2. And that's the final answer for that. So I hope that was useful, guys. Please let me know if you have any more video suggestions or if you need any help on this topic. And thanks for watching. Stay tuned for more content.